Okay, 10.5, other angle relationships. Theorem 10.11. Well, this is almost the same as what we had before, because do you see that this angle is intercepted by this arc? So it's the same relationship. So the measure of angle 2 is 1/2 of the arc of the measure, BCA. So if this is maybe 300 degrees, then this angle right here, angle A, would be 150 degrees. Okay? Now, if this side is 300 degrees, that means that this side is what? Yes, 60 degrees. And so this would make this angle 30 degrees, which is good because 150 plus 30 is 180, and that's a straight line, isn't it? So let's look at an example. Line M is tangent to the circle. Find the indicated measure. So the measure of angle 1 is 1/2 of 132, and that's 66 degrees. Now the measure of the major arc, EFD, let's look at this over here, EFD equals twice 110, which is 220. Theorem 10.12. Angles inside the circle. Now this can be a little tricky here. If two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle in its vertical angle. Blah. That sounds a little bit nasty, isn't it? It's really not that bad. We can get angle 1 by adding up the arc degrees of AB and the arc degrees of CD and dividing it in 2. And then angle 1 is also this other angle because they're vertical angles. We could get angle 2 by adding up BC and AD and then dividing it by 2. So let's see how that works. Okay, let's skip down here to example 2. So let's find the value of this, of x. Well, we know this is intersecting inside, so we can say that 140 plus 112, and then we can take half of that, and we get it. And that is 126. Okay, so you add 140 and 112, divide it in half, and you get x. All right, let's say we don't have 140. Let's make that our unknown. How would we solve it then? Well, we would write x, or we write the angle, which is what? 126, because they would have to give us that one. 126 equals 1/2 of 112 plus x, and then we just solve it to get the x. So the first thing we do is multiply both sides by 2 to get rid of this 1/2, and that is 252 equals 112 plus x. Subtract 112 from both sides, and we get 140. Yay, because that's what we have. So it doesn't matter where the unknown is, whether it's inside the circle or it's the arc on the outside of the circle, we can solve for it. Now, what you do have to pay attention to is to make sure that these are in a line, all three. Like, we can't have the x over here without doing some other calculations. So the two arcs must be with their own angles here. Okay, let's go back up and look at this other theorem. Now, if the angles form outside, so we have lines again, but this time they cross outside instead of inside. Well, it's almost the same thing, except instead of adding this time, we are going to subtract the two measures before dividing it in half. Okay? And it doesn't matter whether they're both tangents, like this, or whether one's a secant. So, let's go ahead and look at that one. I bet we have an example down here. So we're looking for x. We need to take 170 minus the 72. That gives us what, 98? What is a half of 98? It is 49. So x is 49 degrees. Again, it doesn't matter if they gave us this x and our unknown was a 72. We're just going to plug that what numbers they give us into the formula and solve for the other thing. Okay, we're not going to do example 4 yet. We'll probably do that in class. Let's look at the checkpoints. And I want you to do all the checkpoints except for number 4 here. And, here's one of those that you have to solve as an unknown inside the equation. So that'll be interesting, won't it?